So now that you've heard about synchronized collections, let's talk a little bit about how they work in practice. And we'll basically use this in a very interesting way. This is actually a fun test. So there's a test that occurs in my GitHub repository in the EX9 folder. And it uses a synchronized map to compute in cache and retrieve prime numbers. So it's not unlike what we've been talking about with our prime checker app. It's just been factored out into a test case. So let's kind of see what this thing does. So there's a test called run test. And as you can see here, it takes a map called prime cache and a number of iterations. First thing it does is it creates a random number generator. And then it goes through and it runs this code. And what this code is going to do is it's going to check if some number of random numbers are primes, up to max iters random numbers are prime. So the first thing it does is it goes through and it generates a whole bunch of random numbers, basically 0 through less than max iters. So it generates max iters prime numbers. And then we go ahead and we call the compute if absent method on this map, which will check to see whether or not that number is in fact prime. So you can see here we pass in prime candidate and the isPrime method. And so it'll go ahead and add that to the cache, and then it prints the results when it's done. Here is what we do. We go ahead for I equals 0, I less than the number of cores on the machine, and we go ahead and we execute prime checker. So prime checker was this thing that that's a lambda expression, or variable that stores lambda expression. And we run n of them, where n is the number of cores. So all those things would go off and start chugging away. And then what we do for this version is we create a synchronized map using a hash map, and then we run it for max iterations. And so what that's going to do under the hood is it's going to go ahead and execute each of those. It's going to execute this lambda for the number of cores using a synchronized map. And without spoiling the surprise, because we'll talk about the surprise when we talk about concurrent hash maps, which are concurrent collections, not synchronized collections, those approaches are going to be way faster than this approach. And the reason why this approach is suboptimal, even though it works correctly, is because it's only got a single lock. Basically, that object has a single lock, and all these threads are running, doing this computation, and they're all competing for that single lock. So it becomes a contention point where the code will be slower than you might want. When we replace the synchronized map with a concurrent hash map, and if you run the test, you'll see it's a lot faster. But we'll talk about that when we get back from the break, when we talk about concurrent hash map.